Hi, this is Jerry KM4 Zulu Kilo Bravo. Gonna do a follow-up video on our switch here, the remote antenna switch that we've built in the previous 3 videos. Gonna go over how I built this enclosure, how it's mounted in there, and answer just a few questions that have come up pertaining to the switch. One of the most common questions is, how did I bend this piece of sheet metal here that's used for the backer? Now this is a piece of thin gauge aluminum. This same process should work, up to 1/8 of an inch of aluminum. This is far from 1/8 of an inch, but up to 1/8 inch of aluminum should still work. When I built mine, I used several of these sheet metal pliers. You don't have to have a set of tools like this. If you've got any kind of locking pliers, these are vice grips, and I've got 2 or 3 different kinds, and I've accumulated over the years. I didn't buy them all at once. But all you need is a piece of steel, or even any kind of flat stock. I've got a piece of aluminum flat stock here. Either one will work in order to bend your sheet metal. How do you do it? Well, I've got a line here drawn on it that is where I want my bend. You take your piece of metal, whichever one, either one will work basically the same, and you line it up. I'm gonna get a small piece of wood here just to elevate it so I can get the pliers on it easier. Just gonna put it there underneath it. I want to line up the line there with the piece of metal, and just clamp this on. Okay, get that lined up there a little better. Clamp it on. Okay, all you have to do now is push this over. I'm not going to bend this one because I don't need another one right now, and I don't know, I may want to use this for something else. But it's pretty easy. Just you can lay it down like this and just roll these up and get a good bend on that. And once you've got it bent, if you want to, if it's not a perfect 90-degree angle, you can take a hammer and just flatten it out on top of that. Or, if you don't have a piece of angle iron, if you're using flat stock, disconnect your metal from it and you have your 90-degree here. You can put it over the edge of a counter, edge of a piece of wood, anything, to just hammer it flat. It's not that hard. So that's how I bent mine, and you can do yours similar to that. Like I've said, there's hundreds of ways to accomplish the same thing. This is just 2 that I've thought of, in addition to the tools that I had. Think about what tools you have. Think about what resources you have available, and then adapt. Adapt, overcome. Use what you've got. Just like this cabinet here that I built for the switch. This is leftover scrap from another project. I built a 12 by 16 storage shed on my property when I moved up here 4 years ago for my lawnmowers and stuff like that. And this is leftover siding from that project. This is a leftover 1 by 3 that I use for the frame inside here, and just different pieces of scrap wood that I had. And we'll go over this in more detail here in just a second. Okay, the switch is just sitting in the enclosure at the moment. I'm going to take it out and show a little bit of what I've done here. It's got a frame supporting the switch about 1 inch off the bottom, 3/4 of an inch, and that's to clear the bolts as well as the Cat 5 connector. And I've also built a little frame here for this to rest on, and it also prevents any critters or whatever from getting in from the outside. It's a relatively tight fit, but that's what you want. And it sits down there very nicely. And as you can see here on the bottom, you got access to the PL259s. And I've drilled a hole here for the ground wire to go through to connect to the board. And there's also a notch right here, and this is where the Cat 5 cable will go through. And the reason I did a notch instead of a hole is because it's got a connector on the end of it. I didn't want to have to redo that connector. So I notched it out so that it'll lay right in that channel there, and you can close it, and it pretty much seals up around it. And it should keep most all the critters out of it. I've got places to screw in to the back plane here, to the frame. And this is made out of some leftover siding that I had. So the siding by itself, in the States it's called T111 siding, but it's a weatherproof siding. And I put a little stain on it. It didn't even have to be stained because this is weatherproof pretty much on its own. I've built several storage buildings out of this. Built one here after I got here, but I built one at previous places that I've lived, and it holds up very well. Also on the back here, I attached a 2x6. And you can see it's spaced out from the roof of the box here, because this is where I'm going to attach it to the pipe out where the satellite dish used to be. And I'll have to buy some clamps where I can just screw it straight into the 2x6 here, and everything should be good and sturdy. So it's not fancy, it's not 100% weatherproof, but I don't believe it has to be, because these are made to go underneath the hood of a car. It's not 100% weatherproof under the hood of a car either. And a lot of these are actually just right behind the grill at the headlights and such. So I think this should be more than sufficient. We've got room to connect our PL259s down here, and they are also shielded from any water that's running down from the top here, because they'll be underneath the center of the box. And like I say, I think it'll be functional. I'm not a woodworker, as I said before, but I think that this will do the trick. So stay with us till the end. We'll get it out, get it hung on the pole, get it connected up. It's raining today. Hopefully in the next day or two, it'll dry up enough where we can get out and get this thing connected and on the air. Okay, it's a nice sunny day. It's kind of cool. We're going to mount our switch box to the pole here. Now, this is an old pole that was used for satellite dish that no longer being used. So, repurpose. Gonna clamp the switch box to it, and we should be good to go. I've got the Cat 5 cable run through the conduit underneath the ground, underneath the driveway, into the house. Got it terminated in there, connected to the switch. We've got a little over 11 volts coming to the relays, so we don't have an excessive amount of voltage drop. So everything is looking good so far. So let's get the box mounted to the pole here, and I'll have to cut off some of this pole later once I see how high I want to mount it. We'll see if we can get this thing on here now. I've already connected straps just with one screw here, and this is just plumbing strap, and I think this is going to be sufficient to mount it. I will coil up this wire and coax once we get it in place here. Plan on putting it about that high, and got my battery powered screwdriver here. See if we can get one of these screws in on this side. All right, pick it up just a little bit. All right, looks like that's going to do pretty well. And I can put another screw in one of these other holes to pull it down even tighter. But I'm liking that so far. Get this other strap on here. That booger's tight. I wasn't sure how tight those straps would pull it, but it's going to be good, I do believe. I'm going to put another screw in right here in case there's any doubt about it being tight enough. Wow. Sturdy. I do mean sturdy. All right. It doesn't budge at all. Okay, we've got the box mounted, and I've got my Cat 5 in there, and I'm just using a knot in the cable for strain relief right now. I'll probably put some or wire ties on it to help hold it in place. And we've got the main coax feeding in here on the left, the very first connector, and the second connector here is going to our clone of the DX Commander, which is about 20 feet behind us here. So everything's looking good at this point. Going to bring the ground wire up. I soldered on a connector here, and let's bend that a little bit. Yeah, it'll go on the nut there. I believe I brought the correct nut to go on it, and we'll get that grounded. Got too many pockets. There we go. I believe that's the correct nut. Yes. So we'll put that on there. And the end of the wire is in the way, so I'm going to have to get some diagonal cutters and cut off the end of the wire there. I let it stick through a little bit too much when I was soldering it. So be right back. Okay, I brought a couple different pairs of cutters. I wasn't sure which one's going to take to get it. Let's try these here first. All right, yeah, that's going to get the wire out of the way so I can get a nut on there now. I couldn't get a good crimp. Got the end cut off on it here. I need to bend this just to get it the angle that I want it to come in from to attach to the screw. Hopefully I can get that like that. Maybe a little bit too much, something like that, yeah. All right, and we've got a nut. These are stainless steel. Hopefully I can get this thing started on here. This ground strap is pretty heavy gauge. I don't know what the actual gauge is, but it's what they use for electrical grounds here in Kentucky for your home electrical. So that's what they had available. That's what I bought. Get down to the right set of pliers here so I can get in there on that nut, get it tightened down. Could have gotten a socket or a nut driver, but I didn't take the time. There goes one of my noisy neighbors going home from work. Pardon the extra noise there. He got him a nice little Dodge truck, and he likes to hear it. And that's okay. I used to be the same way. Can't complain. I was much noisier than he was when I was close to his age. I'm going to take the coax off connector right now, and I was testing earlier. But it comes, I'll take this other coax off too, this one going to the antenna. All right, now we'll get those repositioned. Do the same thing with the Cat 5, get it out of the way. And since the coax is the larger of all the wires, get this ground wire situated. I'm going to leave a little coil of extra coax right here underneath the switch box, and I will put some zip ties on that later. I don't have them with me at the moment, but this will get us in the ballpark of what I'm wanting to do. Get that reattached. Alright, very good. And we'll get this situated here. There. And right now I'm just going to stick it here behind the ground wire and in front of that just to keep it in place. This other coax is temporary till I get one made up the exact length. I went to make one up today and I didn't have the proper connector. I had connectors for LMR 400 but not for RG8X. So I had to use one that's really made for when I go set up portable for POTA or for other purposes. And there. Now we'll do the same thing with the Cat 5 cable. And I know this looks horrible right now, but we will clean this up and straighten this up on another day. I've been kind of busy today because I had to run the Cat 5 through the conduit underneath the driveway, underneath the house, and so forth. And that takes a while, and it takes a lot out of me too, because having to get underneath the house back and forth and up and down, back and forth takes its toll more than it used to. All right, so we've got the Cat 5 there, ready to plug it in up there, and we'll run it down the side. In fact, I'm going to run it behind that ground wire, trying to keep it away from the RF as much as possible. And we can affix that later with some wire ties that actually screw down, and we can finalize this puppy. That wire back in there like that, close it, and we are connected. Don't only have the one antenna connected now because I'll show you what I've been doing. I've been clearing out trees and undergrowth to make the antenna farm bigger. There is the DX Commander clone, which still is working great. The silver thing there is a metal bowl I'm using for a cover because I need to put my common mode choke into a weatherproof case. One thing at a time. But right now it's still wound on a piece of cutting board, so I need to improve that. But the clearing has gone all the way down here around the side of my hill here. Trying to clear this out so I can put up more antennas permanently. So we'll go inside now and test it. Like I said, I've already checked the voltage out here, and it's between 11 and 12 volts, which is fantastic, and it's going to work well. So now I've got to get some other antennas up so we can have antennas to switch between, because my delta loop and my off-center fed dipole are on the opposite side of the house, but this was the better side for multiple antennas. Going to develop this over time, so stick with us and we will see how things grow. Okay, we're back in the shack here now. We've got our switch mounted outside in its enclosure and have the Cat 5 cable run through the conduit, underneath the driveway, under the house, into the shack now. And got it connected here with a short Cat 5 jumper to socket down at the wall. And the power is currently off. What I've got here, this is the Coax going out to the antenna farm. That's what it has on here, is farm. And what we'll do first is connect to our trusty Nano VNA. Okay, we'll get the antenna connected here. And we're currently on the 10-meter band. Let's change that. We'll scan 1 through 30. Okay, what you'll notice here is we've got the antenna connected, and we've got some peaks on resistance or impedance here, because that's what the magenta line is resistance. But our SWR is way up at the top, and the reason is we don't have any power turned on yet. We're not connected to an antenna. This is just showing the coax and the switch itself. So let's turn on the power, and now we've got some dips at their lowest SWR, which may or may not be close to the resonant frequency. I've been called out on using those terms interchangeably, and I know they're not, and you probably know they're not too. But if you don't, realize that the lowest SWR for your antenna may not be at its resonant frequency. What's the difference, you say? Well, the lowest SWR is based on having the impedance match. You know, most of our radios are expecting 50 ohms, and the antenna ideally should also be at 50 ohms to have a 1-to-1 match. But they rarely are, unless they're, you know, a single band dipole. And there's other exceptions as well, but you know, we'll use a single band dipole that is tuned specifically for that band, no other bands. You're going to get your best possible SWR, and it's most likely going to be close to your resonant frequency, but they're not necessarily at the same point, because resonant frequency is where your antenna is strictly resistive load. In other words, there's no inductive reactance, there's no capacitive reactance. Let's go to the 40-meter band, 7 megahertz, and take a look at that. Okay, with the Smith chart, you can see where your antenna is most resonant, and you see the marker here in the middle. This line across the middle here is where it's purely a resistive load. So the closer you are to that line, the more resonant that antenna is on that particular band. And you notice down here where our markers are, they're not at the lowest SWR. If we go to the lowest SWR, which is more right here, we're right at 50 ohms resistance, as you can see. And it's varying some. And that's not with me in my hands making it vary. That's just the antenna and wind, whatever may be interacting with the antenna out there right now. But it's gone up to about 51 ohms, and we're about 1.05 SWR. Okay, so we have the Smith chart, which is the blue. We got resistance, which is the magenta, and SWR, which is green. And it's fluctuating a little bit there, but somewhere right in there is 50 ohms. So our resonant frequency is around 7.21, and it's also approximately where our SWR is, but they don't necessarily have to be the same, where you get the pure resistive load, or as close to it as you can, and also have the lowest SWR. But, you know, you're saying, does the switch work? Yeah, I'm going to turn the power off to it now. Watch the trace as I turn off the power to the switch. Okay. SWR goes back to the top up here, and the resistance all the way down to almost zero. And why is that? Remember how we built our switch. When the relays are not powered, it shorts everything to ground. And that's what we've got there. So let's turn it back on. Let's go up to 20 meters. And I don't have the Smith chart on here, but we don't have to do that for every band. I was primarily just wanting to illustrate the difference that the resonant frequency is not always at the same point of your lowest SWR. You know, the switch is working fine. I don't have multiple antennas out there right now. You know, I showed you that it's under construction and that I'm clearing out the undergrowth from the woods so I can run more antennas. I've got to do some more work out there. We've got the project completed here now, running on a 12-volt power supply. We're getting between 11 and 12 volts out to the switch, so we don't have a lot of voltage drop going out to the switch, which is good. The relays were functioning even at very low voltage. I've tried that as well. I've taken out the excess Cat 5 cable. I still have some slack on both ends, but I took out close to 100 feet of Cat 5 cable in its final implementation. For right now, the switch in its initial state, where we haven't made any modifications to it yet, is good. It's up and running. And can it be improved? Yes, it can be improved. We will probably be doing that in some future videos. But right now, we're going to move on to some other things. Appreciate your interest in this project. Hopefully it's been beneficial. Hopefully you'll build one. Hopefully you'll share your ideas, what you discover. Leave a comment down below. Give me a like. It helps the YouTube algorithm to push the video out to more people, and it helps the channel to grow. Also, if you would like to help support the channel, I'll put a QR code right up here that you can scan with your phone, and you can donate to the channel. Your donations help to buy more parts and equipment for future builds and testing. Appreciate your watching. Appreciate your comments. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.